So, just to review the key concepts in the lab and try to explain what the lab uh, write-up should really focus on. Let's talk about, what the main question for the lab was. How can you tell if there's been a chemical change? Now, chemical change, as we discussed in class, is a fundamental change. Fundamental. So the example and I gave you numerous examples, but a fundamental example would be if I took a sheet of paper and I told you in class it was made of wood and that wood is made of sugar, and that was actually foreshadowing the next part of the unit. If we took that paper and we ripped it up into shreds, into little squares, so instead of one sheet, we had a bunch of small sheets all stacked up on top of one another. The mass of the two piles would not be different. If we started with 10 grams, we'd end up with 10 grams. What changed here? Well, what changed was the size. If you took some of that away from the next step to the change that you wanted to bring, you took it all away except for one small piece of paper. You might have taken that down to only 0.5 grams now. The mass didn't change here in the first change, but in the second change, the mass did go down. Was that a physical change? Was any of that a physical change, or was that a chemical change? One would, at this point, I hope everyone is able to say that that was a physical change. Now, why was it a physical change and not a chemical change? So we'll have to think about that for just a second while we go on and look at the second part of the example. If I took that sheet of paper and with the writing on it, and instead of ripping it up, I added it to fire. And in that fire, then as that piece of paper burned, it turned into gas, right? Most of it's going to go away. And the gas I told you was going to be CO2 gas. That's carbon dioxide gas. That happens to all things that burn. It's called combustion. And again, that's foreshadowing another unit. After we talk about biomolecules, we're going to eventually we'll talk about what we do with sugars in our bodies, and this is kind of foreshadowing what we're going to be talking about then. So, but in any case, if you burn that paper, it turns into carbon dioxide gas, and then what you're left with on top of that is a small bit of mass, and a lot of you know it as ash. Not ask, but ash. So that paper that was 10 grams now turns into something that might be 0.002 grams. I'm making that up. I have no idea how much mass would be left in the ash after you've burned it. But most of the mass, I know this much, that most of the mass of that paper is going to turn into carbon dioxide. I know that because I know it, not because of anything that I'm telling you here, because I understand the concept of combustion, and that's not the idea that you have to take away from here. What you have to take away from here is that something fundamentally different happened between example A over here and example B over here. Okay? And I wonder if you could, before I explain it, I wonder if you can, and you should know it already, so I shouldn't even have to explain it, but let me go ahead and say that before I go on and try to look at the difference, what happened between this A, from the beginning of A to the end of A, and over here from the beginning of B to the end of B, what's the fundamental difference here? What did we achieve here that did not get achieved over here? So we started over here with paper, and we ended with paper. Its fundamental properties have not changed. Here, this material is paper, and now it's carbon dioxide and ash. One thing became two things, and that one part of it became a gas. It fundamentally changed. For one thing, if you had a letter, there'd be no way to take that carbon dioxide and ash and go back and make it a letter again. Where here, these little bits of paper could be taped back together into one sheet of paper. So that's one way to look at it. That's one clue that this is fundamentally different, right? There's some kind of change happened here that did not happen here. Something changed at the very root of this paper that did not change in this example. And that change was a chemical change. This was a chemical change. And that chemical change is based on the rearrangement of atoms, of elements. That's why I gave you a periodic table. That's why I told you need to know those fundamental atoms, those elements of life. And I said you need to know those. That's an important concept as well. And the reason I wanted you to know those is because those are the elements, those are the atoms that you're going to see over and over and over and over again. Now when we take a look at, and this change over here, a change is actually just a physical change. So when we're looking at how to tell the difference between a chemical and physical change, we have to kind of look at have to try to answer three questions. And those questions are, one, we have to consider the properties of matter that we've discussed in class. So what were those properties? Well, mass, right? We talked about measuring mass. We measured mass. Well, actually, we never measured it, but we talked about it. We measured volume. Weight, I think everyone's familiar with weight. You get on a scale. How much gravity is pulling on you is weight. Mass is how much you have of something. Density is how much you have of something in a space. And color, I think everyone realizes what color is. Phase or state of matter change. And that's, you've been discussing in Mr. Custer's class. It's just this idea that you can go from solid to liquid to gas. Okay. So that's the first thing. Second thing you have to consider if you're going to try to decipher whether you have a chemical or physical change. So you have to ask what kind of changes could happen, and you have a chemical or physical change. Those are the two kinds that we've been talking about. And what you have to ask yourself is, did you change, if it's a chemical change, you change the fundamental nature of it, the atomic arrangement. What do I mean by atomic arrangement? I mean how you put the atoms together. Where in a physical change, you don't change that fundamental nature. That substance is still what it was before. So I'm going to go ahead and just use variables because I think that's probably easier than the examples I gave in class. The examples I gave in class for a chemical change, I used a little bit of a variable as well. I said, if you have calcium, that's one of those elements of life that we talked about, right? One of those kind of sideline elements, so not the fundamental ones. Calcium X, and I said X is a variable, right? So let me use a different color. You have calcium X, and you have some kind of chemical change, what will happen is, for whatever reason, so you mix it with some y, whatever y is, another variable. And what you get is, instead of calcium X, you get calcium Y. I call this a substitution reaction, but it's irrelevant what we call it. The point is, where in the beginning you had calcium combined with some atom here, some element here. It had a certain density, it had a certain color, it had a certain reactivity. You mix it with something, let's say Y, and you end up with calcium Y now, and then you produce something. So you produce two new things, calcium Y and X squared. That's a chemical change. You fundamentally changed the substance. It used to be calcium combined, sharing electrons or combined with X, and now it's calcium combined with Y. Where in a physical change, when you look at a physical change, the only thing that would happen is you would get calcium X, and it would just be less or more of it. There'd be more calcium X or less calcium X if you broke it up or you added some to it, or you pounded it into a different shape, like taking iron and pounding it into a shovel. It would still be iron, it's just in a different shape. So this is not changing the shape, not changing the amount you have, but changing. So if you change the amount or the shape, but not how you arrange the atoms, not the substance itself, not the fundamental nature of it, we call it a physical change. It's the very basic way of looking at the difference between chemical and physical change. Lastly, you have to think about, what's the difference between the different properties of matter? What's the difference between mass, volume, weight, and something like, and properties like density, color, and phase or state of matter? Now this is going to be key. At a particular temperature and pressure. Now this is a little tricky, because you can change the state of matter, most matter. You can change the state of matter by increasing the temperature and boiling it or melting it. Or you can decrease the temperature and freeze it or condense it, right? We looked at a bunch of different examples of water condensing into liquid, from gas to liquid. We looked at a bunch of different examples of things melting. Phase, a change of state, change of matter, a state of matter, when you're changing temperature, and only temperature, when you're not rearranging the atoms, that's a physical change. That's not a chemical change. But if you're producing gas without adding temperature, without increasing temperature, then something else is going on. So this is kind of one of those tricky things. And the example we used in class is, if we get bubbles in the test tube and we're not using heat, then you have to wonder, where is the gas coming from? We're not boiling it. So the answer we talked about in class was that we're not boiling it. What it is that there's something fundamental changing. We'll take a quick look at that, and then I think that should take care of these ideas, key concepts that we're covering in this lab. By the way, these qualities here, this density, color, phase of, or state of matter at a particular temperature and pressure, constant temperature and pressure, we call these things intrinsic. And what we mean by intrinsic is that they're part of that substance. They're defined by the fundamental nature of that substance. So the only way you're going to change these intrinsic properties in general is if you change the fundamental nature of that material. So again, what I mean by fundamental is the arrangement of those atoms. So the example in the very first lab we did in class was to take iron, and we said iron had these properties, right? We said iron is black and it's hard and all these other things that we talked about. And just simply looked at rust. What happens if iron gets mixed with oxygen and changes color and changes it's no longer strong and hard, it flakes off and brittle and falls apart. That's an intrinsic change. Something, its density changed, its color changed. It used to be insoluble in water, it wouldn't dissolve in water. But now after it rusts, it dissolves in water. As you all saw that when the iron was, the rust touched the water became red. It became red because of this intrinsic change. Now there's these other properties. These change all the time depending on something that's extrinsic. And by extrinsic, we mean these are properties that are defined by something that happens outside. Ex, like exit. In, like within. So extrinsic is something like mass. You can add to you can add, if you start with 5 grams and you add a couple more bricks of whatever it is that you want, that you're talking about. I think the example we used in class was gold. If we had an ounce of gold and we added, could we increase the mass without changing its properties and any other properties? Sure, we could just keep adding more or taking some away, right? And then that would be an extrinsic change because all you have to do is take some away or add some. Where intrinsic properties don't matter by how much you have. So extrinsic, so the very basic definition, the one we talked about in class that you'll be tested on, is extrinsic depends on how much you have where extrinsic does not. I'm sorry, reverse that. Intrinsic does not depend on it. Now there are, like I said, there's some tricky parts to this, and that's, the color change. We'll talk about color change later. Color can change, and it not be an intrinsic change because you can mix 2 paints together, and we'll look at that when we look at paper chromatography. We're going to separate some colors, some pigments, some dyes. We'll look more deeply at color later, and that's going to again be very important when we talk about photosynthesis. And when we talk about photosynthesis, the color green becomes very important, and all the colors of the electromagnetic spectrum then really become important and how they interact with electrons. But in any case, a key point here is that intrinsic and extrinsic, the different qualities, the different properties of matter changing make a difference. They give you different clues as to what's going on. in any change, in any one of these changes. Remember, when something changes, it's either chemical or physical. So and you can look at the examples and look at the background and read all the reading you were supposed to do for homework, right? And that brings me to a quick discussion on the different handouts. You had a lab report format. And you went through a practice lab. We did it last 2 weeks ago, and I made videos, 4 or 5 little videos, walking through each of the different steps. But what we did in the lab is we took and we mixed different chemicals together. We did not add any heat. So if there were any bubbles produced, it was probably a good example of a chemical change and not a physical change. We added different chemicals together and we looked to see what happened. So you added A into the test tube, you added A and B, and what you added, well, you have a list, right? You made a table. You have that, and I'm not going to go into that. I'm not going to explain everything. But you have a table. You filled it out. I don't know how many of the reactions or the changes that you were supposed to make. I don't know how many you actually got done, but you added A and B, and some kind of change happened. Maybe nothing happened. You didn't see any. There was no color change. There was nothing. So you just mixed 2 liquids together, or you mixed 2 solids together. Was that a chemical or a physical change? Well, if you're mixing 2 things together, then it's a physical change, right? So you got to go with physical. Now, if, on the other hand, you had a test tube and you added A and B, and when you were done with A and B, after you mixed them, you had any number of things could happen. You had little bubbles forming. Some of you actually had some froth. You added a lot of it, so it even bubbled out to the outside, and it was on the table, on the lab table. I saw it happen in a couple lab groups. That's how much of that gas was made, right? And it pushed the liquid right out and down the side here. So something happened there that was different from what happened previously. You produced a gas, so what was the evidence? So you collected your evidence, right, by your observations. It's a qualitative lab. So 1, you collected, you observed, I hope, bubbles. And I saw the videos that people posted or sent in to, it maybe you went from, maybe you saw a color change, right? At least in one of the changes, there was a color change. Maybe you saw heat. Maybe you felt heat changing. So these are all signs of a chemical reaction. If you mix them together and all that happened was you went from, one dissolved and it kind of nothing really happened. Or there's somebody else I think noticed that there was became cloudy, milky. What was that about? So these are all changes, and your job in the lab, as you do the lab write-up, is to take a look at those changes that you documented in your table and decide, is this evidence of a chemical change or a physical change? When this bubbled up so much that it bubbled up all over the table, was that evidence of a chemical or physical change? And if so, why? So 2 things, right? It's an observational lab, so there's no need to worry about volume or mass. So that kind of limits what you were, it limits what you have to concern yourself with as far as the different properties. You didn't measure density or mass or any of these other properties. you were looking to see what signs were happening. So you're looking for a color change or bubbles or any kind of change that happened when you mix the two things together. And you wrote those down. And then you have an evidence. You have some kind of claim. Your claim is your deciding point. What did you decide? Is it a chemical or physical change? So you have a claim. Then you have a set of evidence. And that evidence is what you observed. So there were bubbles and there was heat and there was a color change. Those are 3 pieces of evidence that you're using to make the claim. All right? And then you have some reasoning for that. Right? So some kind of logic to why you made that decision. And the conclusion check is just for you to write down what are you saying? What is your conclusion? Is it chemical or physical? And then what evidence do you have to support it? Is it logical? Are you contradicting yourself? Did you produce bubbles and then say you're not producing it? Because believe it or not, some people do that. They say we saw bubbles produced, and then in their conclusion they say it's a physical change because there were no bubbles produced. They're contradicting themselves. So just make sure you don't do that. Do your best. Just by completing it, we'll discuss it in class, or we'll discuss it one-on-one. It'll be graded, but I'm not grading for any right or wrong answer per se. I'm grading to see, does your evidence support your claim? Is your reasoning logical? Did you collect the observations? All right, and I gave you detailed step-by-step instructions in your lab write-up, so that should take care of that. I hope this helped. Goodbye.